Hello everybody, my name is Tim Wang-Lee. I'm a signal integrity application scientist at Keysight Technologies. I got my PhD from the University of Colorado in Boulder in 2020.
I'm Stephen Slater. I'm the EDA product line manager for Keysight EDA. So what we're going to be talking about today is Chiplet PHY Designer. But first I'd like to explain a little bit about why chiplet design is going to be so important. So one of the reasons that the chiplets are becoming such a very trendy topic. You'll see the UCIe Consortium and Open Compute project are both promoting and trying to create an ecosystem of individual chiplet players, is because as these individual die sizes are getting bigger and bigger and bigger, you ending up with a bad yield. So you end up with manufacturing issues and then having to throw away too many of the dies. So what you can do instead is try to break up the larger dies into smaller functions, such that even though you'll have issues that therefore you have to throw some dies away, there will still be some that can be utilized. And then what happens is we have to put these together into a package. Now, as you're putting them together in a package, the thing that needs to be created now is die-to-die communication, and that needs to be standardized such that you could have potentially in the future a die from one vendor being able to speak to a die from another vendor. So how are we going to make sure that we have good signal integrity? This is an example that we've been working with AlphaWave, where analyzing this chiplet design in the center. This is a standard and advanced package, and trying to simulate UCIe, which is the standard that's the UCIe Consortium's been working on, and looking at channel compliance and then voltage transfer function, which is something that my colleague Tim is going to jump in and talk more about. So I'd like now to pass over to Tim. I'll give you a demonstration of the simulation tool in action.
Hello, Tim again. Yes, as Stephen mentioned, now the chiplet is a mainstream design philosophy. The die-to-die connection is very important. Let's take a look. On the right here, I'm showing is the bump-to-bump connection for two different chiplets. This bump-to-bump connection is displayed in SI Pro, Signal Integrity Professional. Now, once we have done the EM analysis and extraction, we can pull that information to the left-hand side. That is Keysight EDA Chiplet PHY Designer. The PHY Designer is great because it's very standard focused. Now we look closer on the line here. There are 73 connections in UCIe for this packaging situation. Normally, it has to take 140 connections, 140 clicks to make that happen. But now, with Chiplet PHY Designer, all you need to do is, let's count together, 1, 2, 3, and we'll click on OK as the 4. Boom! Finally, I have to emphasize that the Chiplet PHY Designer is standard focused. So right now we're looking at Universal Chiplet Interconnect Express, the UCIe. But the AIB Advanced Interface Bus is also in the works, and also the BOW, bunch of wire, creative name I know. It's all in the works. And the UCIe is very focused on VTF, like Stephen mentioned, the voltage transfer function, and forwarded clock. We have all of that in our Chiplet PHY Designer. Thanks for joining us at today's Keysight EDA Chiplet PHY Designer demo today. If you would like to learn more, please visit us at keysight.com, type in Chiplet PHY Designer.
Thanks for watching.